And now for section 11.2 series, where we actually add up all of these fractions. So when you add up all of these fractions, does it converge and actually equal a number like 1.2? Or does it diverge and go to infinity? Or it could go to negative infinity. So what's happening here? So in this section, we basically have the partial sums. So we could use the calculator to add up a bunch of these to see what's happening. That doesn't actually prove anything, but it does give us some idea. And the other idea is that it could be a geometric series. And for a geometric series, it's of the form, you have a number in front, and then you've got an r raised to an n. And then that goes from 0 to infinity. And then if the r is less than 1, then this equals just a over 1 minus r. So if I could get it to look like a geometric series, that would definitely help. What's concerning me, though, is it has a 1 plus. With a geometric series, there is no 1 plus. So what could we do about that? Oh, I know. You could divide that into two fractions, keeping the common denominator, the 3 to the n, and then break up the numerator into two parts. So we really have two fractions, and then take the sum as n goes to 1 to infinity. And then each one of these looks like a geometric series. I know you're saying it's supposed to start at n equals 0, but just hold your horses. Wait a second. So this one could be rewritten as 1 over 3 to the n, so it looks just like a geometric series. And the second one could be rewritten as 5/3 to the n. And the only way that a geometric series converges is if the r, when you take absolute value, is less than 1. So with this one, it's basically two series. With this one, the r is equal to 1/3. That means the first one, which is then going to get a nice blue smiley face because it converges. The r is less than 1. But for the second one, the r is 5/3, and because that is bigger than 1, it diverges. And so it doesn't really matter how well behaved the blue smiley face was. If the second one is going to add up to infinity, it doesn't really matter what the first one adds up to, because the second one, which is going to be the red smiley face, is saying, haha, I've hijacked our train, I'm taking us to an infinity. So that means if it goes to infinity, it diverges.